Thank you for reminding. So I think we have the scatter plot. I think you can just run through these. Oops, I have an error here. So let me just copy these. Oops. And I think it should work. And you can see it's kind of we have the clusters. I think our data is just clustered into three clusters. But this one is just by drawing of just scatter. We have not used any algorithm or anything. But this is just the representation of the data that we have. The scatter things that we have, maybe we have three clusters. But we are going to see that right now. But this is the scatter plot for our data. It's kind of we have three clusters. You can even call it cluster A, cluster B, cluster C. But I think you can just move on and just try to to use the algorithm here and see what we are going to get after using this algorithm. So how it's quite similar to how we use the other algorithms. So it's just KM to means K means, and then we just have the K mean, K means. Then what do we pass in here? So with the K means, with the K means here, you must pass the number of clusters that you want to cluster your data. But I'll show you how to get the. It's not all the times that you're going to get at when you draw a scatter plot. Maybe it will give you a hint of how many clusters you're going to have. Some data is a bit messy, or maybe even it has, maybe let's say, more columns. So it's not all data that will be so obvious when you draw a scatter plot that you are able maybe to determine the number of clusters that you have. I'll show you how you can determine that. There is something we call the elbow technique. So we are going to see how to do that. So in this case, it was quite straight that we have a number of clusters. There are three, just from the scatter plot. So I think you can just pass that. Uh, Clusters is equals to 3. So it k means, then you just pass one argument. That is the number of clusters. Then after that, I think you can just have the y underscore predicted. Predicted is equals to the km dot fit. So we train our model. So in the training the model, again, you just have to pass uh, your data here. So in this case, we just want to pass df, let's pass, just pass into two columns, that is the age and income. So after passing that, I think you can just even try and see what I predicted has. And I can see we have an issue here. Should be K. This one should be M, capital M. K means, and I don't know what we imported here. Good. I think you can just run through this and see what we have. I think this one should give us an array of. Let me just try to print. Should give us an array of numbers, but it's just giving us how I predicted that we have the three clusters. I think it should give us an array of numbers. I don't know. I don't know what could be the issue, but it's still okay. It's just giving us three clusters. I think you can let's just try to add these were predicted into a column and see what you're going to get. If you guys, you can remember how we add a new column into a data set. So it's df, then let's have column called clusters. Now we can just call it cluster is equals to y underscore predicted, and see what we have. And here new df dot head. I think it should have given us some. I think we have a problem here. Should give us an array of numbers. I don't know what is not happening here. Yes, I missed something here. It should be km.fit underscore predict. These are some of the errors that you get, the syntax errors. It should be fit, this one, fit predict. So you should note the difference in syntax. With the previous algorithms, we have been using fit. But with this now, you have fit underscore predict to train your model. So these are some of the things that you should note with different algorithms. I think even yesterday you just noticed that again with you notice some differences with SVC. So again with k-means, you notice that you are passing an argument of the n underscore the number of clusters, and again when training your model, you use the fit underscore predict. So I think you can just try to run these, and now we have we have a series of numbers here, or maybe array of numbers. So these numbers, they just mean that our model has three clusters. That is 0, 1, and 2. So I think that is it. And I think you can just add these to our you can add the cluster column in our data set. So if we just try to run these, we should be able now to get we should be able to get the categories here, all the clusters. You can see that a salary of 70,000 is classified as one. We have the salary of 90,000 classified as two. You have the salary of 61 clustered as one. You notice that these now salaries are clustered into three clusters. That is 0, 1, 1, and 2. And if you maybe were to just print out maybe the first 10 rows, you notice that we have salaries of 155,000 classified as 0, 150. Like we don't know what the criteria that was used by this model to place these salaries or this income. But I think you can easily tell that the guys who are earning most, they are clustered as 0, because you can see the salaries of 150, 155, 162, 156, 130, they are all classified. I think you can just even have maybe the first 20 rows. You can see even the 137 is also clustered as 0. So this is what I was saying, that this model, they will just help us to to cluster some to cluster your data based on maybe several characteristics. Like in this case, you can see we were just considering the income here, and we can see the maybe you can say maybe people of maybe people earning over 100,000, they are clustered as 0, and people earning maybe in the range of let's say maybe from 80 to 99,000, they are clustered as, I think, 1. I think from now, yeah, from 70,000. No, 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 no. Let me see the list here. That is 48. I think we have a group of people who are running maybe 80,000 and above. Yeah, between 80 and 99,000. You can see that they are classified as 2, and people earning below that, they are classified as now 1. So you notice that we have now 3 clusters. Our data is classified into 3 clusters. But I think I told you I can show you how to. Okay, before even we get to the elbow technique of determining the number of clusters. So just to understand how this algorithm works, what normally happens, maybe I can just explain a little bit on how this algorithm works. Now the theory part of it. So in KM we have something we call cluster centers. And what normally happens is that let's say we just have like to identify, like in this case, maybe let's assume we had maybe, I think I don't know if I don't have something like I can draw with here, but assume at this point we have something like the X cluster, and maybe somewhere here we have something like maybe let's say Y. So what normally happens, we usually draw we usually connect the two, uh, we usually connect the two centers. That is not really we call it them centroids. If I can remember that very well, there is something that we call centroids. You can just begin by putting them in you put them just in a random place, and that is why I'm saying that you can just have an X here and Y here. So you just connect the line, that is the point X and Y, and after connecting them at any random place between your data, then you just have to draw a perpendicular line between your values, that is X and Y. They are imaginary because I don't have something to draw. Maybe um, I don't, yeah, I don't have something like to draw here. I would have draw it very well. But just assume that we have X here and we have Y here. So we just connect the X and Y, and we just draw a perpendicular line that is between the X and Y. Then after doing that, you just have now to compute the distance of every point from now the centroid. The centroid here will be the point at which line XY meet, um, where the perpendicular line intersects the X and Y. So you just now like compute the distance of every point. That is the points, now these points here, the data points, and the center. So based on the distance between the center where these lines have intersected and data points, so you just now compute the distance of every point from the centroid, and now you cluster them accordingly. So those points that are maybe far away from the center, maybe towards a certain direction, you notice that they are clustered. They are clustered to be maybe one cluster, and also the others are also now clustered to. They are clustered based on the distance. So what now normally happens? We are going to adjust those centroid so that they become the center for gravity for maybe a given cluster. So we are going to adjust that line. We are going to keep adjusting. We adjust until we get the we get the appropriate centroid that is now between all the clusters. I think if I had, I wish I had a diagram. Maybe I would show it better. But that is what normally happens, and that is why I'm going to show you how to even determine the number of clusters that you can use in your model. Now using the elbow technique, I think we are just going to have that very fast. So I think even before that, I think I can just show you the clusters that are used here by just calling the km dot the cluster centers that are used in this one. We call them the cluster centers. If I was just to run through these, you can see we have an array of values which are our cluster centers in this case. These are the cluster centers that are used to even do the classification of the data set that we have in here. Maybe before we get into even calculating the number of clusters using the elbow technique, I think we can divide our data into three data frames, and also show that we show that in a scatter plot. So how we do that is just, now that we know our data set is divided into three, we can also like have data frames for each category. So we can just have df1 is equals to df, and then what do we add here? We have the categories. You notice that we had these three categories here. That is the data is categories to 0, 1, and 2. So meaning that we can have the three data frames here. So how do we do that? So we can have df, and we say that now df dot cluster if this one is equals to 0, we call it our df1. I think you can just show that by even having a df1 here. This one is just going to give us the data set, the data for which cluster is 0. Then we can have a df2. I think with this one we are going to classify or to draw a better plot, a better scatter plot, I mean. So we can have df2. Let's have df2. And in df2 we just need df dot cluster dot cluster is equals now to 1, and also you can have df2 is equals to df let me just call that one 3. So I think you can just this one should be df3, not df2. So you can also check the df2 df2, and you notice that you are going to get all the data with ones. You can also check the df3 now, just to make sure that you are getting the clusters where we have two. So I think now after this we can draw a better scatter plot, and we are going to have the scatter for df1, the scatter for df2, and the scatter for df3. So very fast, I think now you guys are familiar with how we draw the scatter plot. So it's plt dot scatter. Very fast scatter, and what do we want? What do we want to pass here? That is the df1 now. df1 dot h. This one should be a comma, and then we have the df1 for the income. It should be income, and this one is in dollars. And maybe we can even specify the color. We have attribute for color here. I think this one you can just represent it with maybe color green. Hoping this one should be fine, and this one should be into quotation. So can you just try out this and see what we have? So that is our first scatter. I need us to have all the three scatters in one in one in one in one in one plot. So you can copy paste this one 3 times. And change this one to oops. We can change this one to D2. Oops. So DF2. And with this one, we can just change the color to be maybe blue. And we can have the third one now. We can just change that very fast, DF3. I think this one can use black. So I think we can just run through this and see what we have. Good. So we have our three scatters. That is for DF1, DF2, and DF3. But now having specified the colors, you notice that our data here. This one is well clustered, but for the cases of the blue, I think we have some black data points. They are getting like misclassified, right? Because you can as well as see that we have in this scatter here, or in this cluster, we have some black data points, and also in these black data points we have some blue data points. But what could cause this? This is simply because if you were to check how our data here is kind of distributed, we need to scale this so that we can at least have our values from maybe 0 to 1. We need to scale this, and so that we can at least have the reason why we have this is just because of these big values here. Not They are not scaled. So, and in the k means we have something that is called we have the min max scaler that will help us to scale. That is the y-axis value, and also the x-axis value, so that we can at least have these black and blue clusters being on the own. So how do we do that? I think you can just start by importing that min max scaler. We can just do it here. And how do we do that? That is from also sklearn that is dot pre-processing. It's just there. We need to import that is the min max. I think is usually like this scalar. Should be like that, the min max scalar. So this min max scalar will help us to scale our that is the x-axis and y-axis value. And it's quite simple how we do that. It's just quite very simple how we do this. I'm just going to create an instance of our, but maybe before after we get to the to scaling our y-axis and x-axis, maybe we should maybe try to make this one look better by having the labels for the x, the y and x, the y axis and labels for y and x axis. And I think you know how we do that. I think you can just have it right below here. Hash label in axis. Let me just do that very fast. That is the plt dot x label. And on the x-axis, we just need the label age. And we need the plt dot y label. And you can have this as the income. I think that one is better. So I think we can also add the cluster centers. Let's see how we can add the cluster centers here also in our scatter. It's not something that is difficult. Let's have the plt. I think I should indicate that. Adding the cluster centers. The scatter plot. It's not something that is difficult. So you can have the plt dot scatter. So we are going to begin with the cluster centers for the zero cluster. So we're just going to have the km dot cluster center, and then we just want to make sure that we are using all the values in zero. Then we can have km dot the cluster centers. I think this is the right syntax if I'm not wrong. I should have for one again, then km dot cluster centers for the two. Then I think we should just identify, we should have the You can just use different color here. Let's just add a different color, or maybe something like, which color do you suggest we use? I think for ladies we'll go for purple. You can we can use that. Um, let us just try to rerun this. Oops, and we are getting some errors here. I don't know what is the issue. Let's see this. We are told that index 2 is out of bound. I think we should do away with this. Let's just add the marker. In this case, we just want to use the asterisk, and we can even add label for this. I think I can just use centroid. The reason why I'm using this is it's because I'm about to add something in this graph that is called LangChain. I think for those of us who did an extensive maybe research on these plots, I think you came across something that is called LangChain, right? I'm just assuming that you guys did maybe extensive research on drawing these plots. So I think you should be able to get that right. And you notice for now every cluster here we have we have the cluster center for that for that for that cluster. We have all the cluster centers. You notice that in here we have a cluster center for this cluster one. We can call this one cluster one. We have another cluster center in this maybe cluster B, and also we have another center, a cluster center here for this, maybe we can call it cluster C. So I think I can add something that is called LangChain. Let's see how it works. Hello. Let me just use it, plt.langchain. I think when it appears somewhere in the graph, you'll know what we have added. And you notice we are just having the center. We have it's because I didn't indicate the other I think by default it should have added these. Let me just add them. So in here we can just call it. We have the marker. Let me have the marker here. I think I can add the marker also in this. And the marker in here, I just want to use think I can add O. Let me also add here. Maybe a dot. Just try to use that. I don't know if it will work. Oops. Let me also add the label. It is in dollars. I think now it makes sense. This is what we call a legend. This one, just indicating that what we have in our graph here. So the asterisk here represent the centroid that I was just saying, and we have the other labels for. We have the green label for the cluster for income. We have also a blue another cluster for income, and we have black another cluster for income. I think now this graph now make sense because we have now labeled it well. So I think before we got into that, I was saying that we can add so that we can avoid misclassification. We can scale our y and the x values, and that is what I want us to use to do right now. Uh, and this one is just part of pre-processing our data. Let's call it pre-processing. Let's see this. Pre-processing using the mean, it's called the min max scalar. So I think you can just create an instance of this scalar. Scalar is equals to, it's just quite direct, the min max scalar. I think it's just right here. And then where do we want to use our scalar? So we just want to use the scalar to fit our income here. Let me just have we just want to fit our income. And how do we do that? I just say the df, then we go into the income column. Okay, then we say that our new column for income now will be, let's see, this will be equals to what? Scalar dot, we want to do some transformation. So it's scalar dot transform. Then we just pass in our df. That is the income. So that is how that is how we use the scalar. And just having this, we're just like using the scalar dot fit. We just want to scale the income column, and we are assigning these to the transformation. So it's scalar dot transform, and then we just pass in our column here. So if we were now to if we were to have our data set now df dot maybe head, I think you are going to see something. Oops, there is an error somewhere here. We are told that the min max scalar is not defined. I think if this is the problem coming from this, we didn't run this. Let's see if the problem is solved. Good. And now you notice that our income here, let's just see the first 20 rows. You notice that our income here has been scaled. Has been scaled. That is in this scale, that is from 0 to 1. If you were just to go through, you cannot see income greater than 1. The highest income is 1 at 1. So we can also do this one for age very fast. This one is the income. Let me just indicate that income scaled. Let's have our age. Again, it's just quite similar, so I think I can just copy this very fast and change some few parameters. So what do I change here? That is the income. You can just I can just change this one very fast. Just have to delete that. And add age. I'm hoping I didn't have an error in doing that. I think we'll have an issue here. So let me just edit one by one. I like using shortcuts. This one should be age. And also this one should be age. Oops. Let me see this. I think now we are good. Let's try that again. Oops. I think we just scaled age also. You can see that we have a column age that now has what? Has the values between 0 and 1. So now I think with this now, we should be able to do the scatter. We should be able to do the scatter. And I don't know why we replicated these, but that is something we can just drop. That is no issue. So let's use this data now to do a scatter very fast. I think you can just draw the scatter here. Let me have this. Let's just try with one. That is the PLT dot scatter. And then in here, we just pass in the df dot edge. Then we have df what? You can have the income here. Let's see these PLT scatter. Good. And now you notice that we are, I think we have a problem here. With the X values. I don't know what happened. Let me see this. So I think because we have, oh, oops, we had an issue here. Yes, I think it should be like this now. Let's try to draw that. Yeah, and now you notice that our y-axis here, we have the smallest value is 0.0 and the highest value is 1.0. And so do the x-axis, that is 0.0 to 1.1. So now having this, if you are just to draw maybe the same plot using this, if you are maybe even to replicate this, um, if you were to replicate this somewhere below here, let me just, I think, rerun this and see what we have. Oops. I think you're going to get some errors because I'm going to get some errors because we have used df1s, df2s here, which are not known to our code up to that point. And you can still see we're still using the unscaled data. So I think it better just we use this one. It's going just to take more time to correct this code, but you can just try it. You can just try that on your own because I can see time imesonga and we haven't covered something all what you are supposed to cover. So do we have any question up to that point? That is anything concerning the implementation of k-means. I think I can just take questions before we get to the elbow technique of determining the number of clusters that you are going to use. Any question? But I think then if there is no question, I think we can just go through. We can draw. We can just draw these very fast with a scaled data. I think you can go through it very fast, so that we make sure that we have all the data classified well. So let me just go through that very fast, and maybe we can just we can have just the km is equals to the k means. Let's just use this. The k means, and I use the n number of clusters is equals to 3. Then we just have our y predicted now to be y predicted is equals to that is the km dot. We just use the fit predict, and then we just have to pass our df. Our df in here, we just want to use the age column and the income. And the income is in dollars. So I think you can just have that and even have a y predicted now here. I think you can just try to see the y predicted just to make sure that we have the right values. And you can also see that even with the scaled data, we still have three categories. That is 0, 1, 1, and 2. So I think you can you can assign this one to our new data. You can pass this one to our new. We can add a new column, and how we do that is just df, and then we just pass the name of the column, which is a cluster, and then we equate this one to the y underscore predicted. I think should be like that. Let's see that. Let's have df dot head just to make sure that we have the right data with us. Yes, and I think we are good up to that point. So I don't know why I'm getting two age. I have age here, income cluster, then I have another age bracket cluster. I think we have a bug here. Let's just go through that very fast because I don't know why we are getting that. And also you guys, I think you should help me to to check that. I don't know where I'm getting that bug from. We have the scalar is equals to min max fit income. We have the age. Where is this coming from? Copy. Let me just find these. I think you shouldn't be getting these.
Excuse James, try running everything kutoka juu. Try running kila kitu kutoka tu kwenye ulikuwa na load environment, itapotea.
Itaenda because I think I have. You shouldn't be having columns of. I think that is the problem with now these working with cells. I predicted, I think up to this point we are good. What about the cluster centers? They are good. I think up to that point we are okay. I see these now. These giants. Good. I think we have it. Yeah, Kube, the issue was, I think it's sorted. I think I can also run these and also rerun these. Now we have clusters. These ones should be cluster. Hey, we have two clusters again. Oops. Let me just try to do away with one. I think we have some issues with these. But I don't think that one will affect our output. So I'll not have to run through this again. Yes. Lucy.
Okay, maybe we can check on the code or where we did the minimax scalar. I think that is where the problem started.
Oh, you are doing this one. Let me see.
Yes, you see, I think that is where the problem started. I'm not certain, but I think from that time it's when we had two edges. But it's that.
because we have the scalar is equals to field, but this is just a small problem here. Because if I run, does it mean there is somewhere I added two columns? Because at this point I have just one. Now let me just try to rerun these. Maybe we will have a problem being solved. Because at that point we are okay. At this point I don't have any problem. At this point again I don't have problem. Now we have the cluster is equals to y predicted. I think up to that point we are good. And even up to point where we are checking the cluster centers. So even up to this point, I think we are good. Good. Because even okay. Let me now check from here where we have pre-processing. I think the issue has been solved again by running through the code. Okay, let me try to run this now. Good. I think we are good now. Yeah, now this is the data that we should use now to draw the scatters. Let me maybe add something here. The scatter plot. And it's just quite easy because I think even you can now copy this. I don't like because this code is quite repetitive. I think you can just copy that. I don't like writing the same code many times. And I think what should we change now? I think we have df1 dot age, and we have the income part. The income part and the color. I think you can just do away with all these shit. Let me just try to use this as red. That you can have green, red, black. And I don't know what is the problem again. I think our problem should be solved with this. Where is this green coming from? Do we have a green? You have green. I think there is somewhere we have a problem here. We have df2.age. Just want to see where the problem is with this one. There must be somewhere something somewhere is not working out. What do I have in df1? Let's just try to debug this one very fast. I think with the df1 we are good, and we can see that the income is 0.7, 0.78. Let me see also the df2s. The df3s. I think we should be able to come up with a very good scatter plot. Sometimes these codes they can they can disappoint you. I see this. These values they shouldn't be at this range. Oh, oh. I think the problem is just here. Can we just have the labels, just the labels, because yeah, let me just try out these, because I can see there is a problem with this scale in here. I think up to this point we are good. When we put the labeling the axis, but now when we put some data is where we are getting some issues. Because with this one everything was good. Let me copy that here. And in this case we just want to use the df1. But again you are getting some values that they do not make sense to everyone. Okay, I'll check through these. I think I'll check through these because we shouldn't have these labels as these. I think I'll check that. I'll go through that and come up with a solution. Okay, is there any other question apart from what we are, the errors that we are getting in here? Any question up to that point? Do we have any question?
I have one.
Yes, ask.
Okay, I've been trying to put legend on my grass, but it's only showing for centroids. Maybe can you tell me what could be the problem?
Sorry, I didn't hear you well.
I've been trying to put legend on the grass,
Yeah.
but mine is not showing. It's only showing for red.
Yeah, can you share what you have?
Okay, enough. Let me switch to my laptop and then I share. I was joining the meeting with the phone and then using the laptop. I hope you can see the screen.
Let me check. Yes, we're able to see your screen. You just have the centroid.
Yes.
I think it's because you haven't added labeled marker. Can you just try to scroll up? Yeah, you should add a label. That is for the three. Where we have the the DF1, DF2, DF3, you should add a label at the end. You can just add a label for the DF1. You can just call the labels income. Do you know what to add that? No, not see hapo. Where we have the PLT dot scatter. At the end, after marker, you add label. Yes. The label is equals to maybe income. It should be in quotes. I think you can just try to rerun. I think you have it now, right?
Yes, thank you.
Okay, any other question? I think if there is no question, I think you can. For the last remaining minutes, I think you can. I'll figure out what is the issue with this one, and I'll share the code with you. So, but we before we finish up, I think you can just try to use the elbow technique to determine the number of clusters that you're going to use. And it's just quite easy how we you can have the elbow plot here. I call it elbow plot. So okay, let's just have the code for that. And to draw the elbow plot, we must calculate we call it the squared the mean squared error. So I think you can just have SS as an empty array. So then we can have maybe k underscore the range. Can give it a range of maybe 1 to 10. I think you guys know how we do the range. We run the range of 1 to 10. And we can have for what? For k in k underscore range. Just use the k-means algorithm. K-means is equals to, then you just pass the number of clusters. Clusters is equals to k. Is just it's kind of we are trying to find we want to find the number of clusters that we can use. Between that is 1 to 10. Then after that, I think we can have km dot feet, and then our df. df we have age, comma, we have the income. The income is in dollars. So what else do we need? So we need to append some values to our SSC. That is the SSC dot append some values here. And the values that we want to append is the km there's something we call inertia. This one, it's called inertia, if I'm not wrong. So this km dot inertia will hold all the values for the squared mean error. So let's I think that is it, if I'm not wrong, and even you can just try to plot these. And you can have plt dot x label. Just pass in the our k, and we can have the plt dot y label. It's called the sum of the squared error. Let me have it. Sum of squared error. The reason why we use the squared error is to eliminate any negative value, because you understand when you square a negative number, you get a positive number. That is why we are using the we square the error. I think you can have now the plot plt dot we plot what? We plot the k range against the sum of squared error. So let's see what we have by these. I think you can just run us of these. I'm hoping we come up with this one. If you can see, if you were to check this graph clearly, you notice we have this graph it's kinda an elbow, right? It's kind of an elbow. That is why we call it the elbow technique, to determine the number of clusters that you're going to use. And now what we do is just noting the point at where we have a very sharp, just like elbow, the sharp point of maybe when you try to fold your hand, there is always that part that maybe protrudes. So in this case, you can see it's at where we have 3, right? I think we have a question from. Is it a question?
Yeah, it's not a question. Your screen is blank. We are not seeing anything.
Is it from your side or is from everybody's side?
Maybe you
I
can
can
just
see.
confirm.
Maybe it's from your side. Dickens.
Yes.
I think it's from your side because I think the rest can see. Are you guys able to see the screen?
Yes.
Yes, I think maybe you can just try to refresh. Yes, at this sharp point, you always check now the value that it's the value at the x-axis, and you can see the number of clusters that you're going to use. So you can always whenever you have a data set, you can always just have these they are not more than 10 lines of code to determine the number of clusters that you are going to use based on the data set that you have, because some data sets will be messy and when you do the scatter plot like the one we did, you might not be able to tell the number of clusters that you are going to use in your model. But that is how we just approach it. So I think what I'm going to check is where you are not able to draw a scatter plot with the squared with these scaled values. I'll check. I'll go through it, and then I'll share the complete code for that. I think there is maybe some issues with how we are putting our data here, but I'll go through it. So any other question before we drop off? I had said that I'll share an exercise. Okay, a question from that is Lucy.
Okay, I was asking, I didn't quite get how you're not going to get the number of clusters from the elbow plot.
Now the elbow plot. So we are saying whenever you draw this plot, I think you can see it just looks like an elbow, right? So as you can just check here, we have a point where we have something that looks like an elbow. This sharp point here. Because if you were to compare, maybe these ones look like a sharp point, but you cannot compare it to what we have here. I think this one is the sharpest of all. So you just have to read the number that it is at x-axis, and even you had labeled that as k, or even maybe we can change that one to something that you can understand, the number of cluster to use in k means. I think we can have it as such. Lucy, are we together up to that point?
Yes.
Yes, you just have to check the elbow, these sharp point here. Any other question? I think you can see also the different algorithms. They have their own complexities, so you can't compare these now k-means to what you are just doing with linear regression, and so they have different levels of complexity, and you're going to see even the other algorithms. Maybe this one is also simplest, compared to maybe others. But we are going to see that. So if there is no question, I think I can wish you guys a good night. Another question?
Not really. I was dropping my hand.
Okay. I think you guys, you can have a good night. We see each other tomorrow. Yes, at 6:20. And you understand that tomorrow is the final class with these with Python. So you should join early. That is as early as 6:20, so that we at least cover some another one algorithm. So you guys have a good night.
Good night.
Thank you, and same.